y equals to ln x means y equals to log base e x. So basically it's a logarithm. E is 2.71828. So y equals to ln x is, this is the x-axis, this is the y-axis, this is the origin, and the shape looks like this. It becomes parallel to this y-axis, comes very close, and cuts the x-axis at the point 1. If I were to sketch this without the y-axis, it would look like this. This is the x-axis, and there would be a vertical asymptote over here, and which the ln x cannot cross. So it would be like this. It would come very close, but not touch that or cross that. So this is cutting the x-axis at 1. So when we have any transformation with this, for example, y equals to ln of twice x, y equals to ln of thrice x, y equals to ln of 4x. Basically, y equals to ln of a constant multiplied by x. What is happening over here is that this is the x-axis. The vertical asymptote would continue to be x equals to 0, meaning the y-axis. It would be now, instead of passing through the point 1, it would pass through the reciprocal of the coefficient. So if it is 2, this would be half. If it is 3, this would be 1/3, and on and on. Let me show you the graph plotter. So this is y equals to ln x, and this is, if we zoom in, we can see that the vertical asymptote, y-axis, or x equal to 0, it comes very close to that. So if we have y equals to ln twice x, it looks like this. It used to cut at the point 1. Now when we put 2, it is not cutting at that point anymore. It is cutting at 1/2. Then if we have 3, it is here. This is 1/3. If we have 4 over here, so this is 0.25. If we have, okay, let's go back to ln x again. If we have 5, then this is 1/5. So this is what's happening. The shape is changing a little bit, but it is cutting the x-axis at the point, the reciprocal of the coefficient of x. On the other hand, if we have a coefficient in front of ln x, for example 2 ln x, or 3 ln x, or 4 ln x, or 5 ln x, and on and on, so we have the format of y equals to a ln x, it would not be visible in the sketch that we do. So that means in all the cases, our sketching would be like this. This is the sketch. It would pass through the point 1, and whatever changes there are in the sketch, it would not be visible in the rough sketch that we have. So let me show you here. So what you need to pay attention to over here is the point here. This is 1. It passes through 1 and it is parallel to the y-axis. If I write 2 over here, this is 2 ln x. Now notice it is still passing through the point 1. It is still parallel to the asymptote, the y-axis, x equals to 0. But the shape has changed a little bit. Now let's go back to ln x again, and now let me write 3 ln x. This is it. It's the same. The shape has changed, but it's passing through the point 1 and it is still parallel to the y-axis. Now if I write 5, so it has become a lot straighter than before, and but it passes through the point 1 and still parallel to the y-axis. Now this concept is one of the most important concepts of sketching natural logarithms. When you have y equals to ln, some number, some constant added or some constant subtracted, it means basically it is shifting towards the left. If it is some number added, for example y equals to ln x plus 1, so what would happen? If this is the y-axis and this is the x-axis, the asymptote, instead of 0 on the y-axis, it would be over here. It has shifted by 1 unit towards the right, towards the left, and this is also, it would be like this. It would be like, previously it was at, no, it would pass through the origin in this particular case, because it was previously passing through 1. So if shifts 1 unit towards the left, it would pass through the origin. Now if we have something like y equals to ln x plus 3, this sketch would be, so the number that is added with x, that becomes the asymptote. So this is the vertical asymptote. So previously it was at 0. Now this would be at -3. And this time, so this was at 1. So this would be shifted 3 units. So this would be -2. Now notice here, this time it is cutting the y-axis at a particular point. Now in order to find that, what we do is write at the y-axis x equals to 0. So y equals to ln 0 plus 3 is ln 3. So this point is going to be ln 3. So it's going to cut the y-axis at the point ln 3. So this is y equals to ln x. If I write ln x plus 1, it shifts towards the left and it cuts the origin, passes through the origin. And here, this is the vertical asymptote. This is 1 minus x equals to -1. Now let's go back again. Now if I write plus 2, now from 1 it goes to -1. It shifts 2 unit, 1, 2, 2 unit towards the left, and the vertical asymptote also shifts. Now if I write y equals to ln x plus 5, that means it was here at 1, now it is at cutting the x-axis at -4, and the vertical asymptote is over here. And remember, here it is cutting the y-axis also, which you can figure out by putting the value of x equals to 0. We know y equals to ln x is basically a logarithm. So y equals to base ex. So e is 2.71828, so 2.7. So what about the sketching of y equals to log base twice x, y equals to log base thrice x, y equals to log base 4x, basically y equals to log any constant x. Is it possible to, when we do a rough sketch of that, how does it change the overall picture? Well, it doesn't change much. So the sketching of y equals to ln log base 2x, log base 3x, log base 4x, log base x, or log base ex, that is ln x, is the same when we do the rough sketch. So it is going to be like this. We have a y-axis, we have an x-axis, we have the origin, and it is going to be like this. So it is going to cut the x-axis at the point 1, and it is going to be parallel to the asymptote, which is x equals to 0.